is into beer, and so tonight he is bringing you a story of the terroir. Pronunciation? Yeah. Terroir. Close enough. The story of what's in your pint glasses.
Okay, cool. So that was a pretty good icebreaker. I'm not sure I'll be as good as our last presenter, but I'll do my best. So the title of this presentation is Botanicals, the Building Blocks of Good Beer. And just to give you a little bit of myself, obviously you can see I have a lot to say about myself. What's relevant here, I'm an IPM crop consultant. I've been doing this for 8 years. Currently I'm 27. I'm a home brewer, which does not put me on the same level as anybody over here who's doing beer, professionally of course. But I wanted to talk about this particular subject because one, we were going to be at a brewery anyways, and two, I do home brew, and I thought that some of my experiences I could impart to you guys in the audience. One of those things being that there's no accounting for taste. And I know typically people say that in sort of a pejorative manner, like, oh, well, there's no accounting for taste, you like this and I don't. But it's kind of true. What you like and what you don't like is going to be different depending on who you are individually. And of course, there are memes and there's something to be said of where you grow up and what you're exposed to and what you're sort of made to appreciate and like over time. But I know a story about a home brewer who wanted to he wanted to boat brew. He was very into sailing, and he wanted to brew on his yacht or something. And it came to be that as he was brewing, see, one of the really important things about brewing beer is and other kinds of alcohol is temperature control. But on his yacht, he couldn't do that really. But he didn't know, and he didn't care because he was all into making the beer. Well, it turns out that because of the temperature changes, he would get a lot of what are called fusel alcohols. And fusel alcohols are bad alcohols, isopropyl and amyl alcohols we're very sensitive to it because usually they give off a warning to us that means don't drink this, it's poisonous. And with other alcohols, we can kind of let that go aside. But we're very sensitive generally to this, and it's an evolutionary thing. And he had a lot more of that ostensibly in his brew. And when he would try to brew it, when he tried to brew his house, he's like, wow, like this doesn't taste the same. And it doesn't. And to him, he became nostalgic for the not very good beer that he used to make on his yachts. So there's no accounting for taste. Okay. And I have business cards if you're interested. I consult. I do a lot of pro bono work for gardeners and things like that because I'm interested in helping people out. I guess it'd be a little bit of a blur, but every single day we're just one bad package away from like someplace in another country, some sort of organic material that somebody gets that could be full of pests, pathogens, things like this. Huang Long bean or citrus greening is a big problem here in San Diego, Orange County, things like this. It's a little bug. It's a bacteria actually that's vectored by a small insect. And like the CDFA tries its best to make sure we don't have this problem, but of course we do. And the reason I bring this up is because one of the reasons why I do pro bono work is because I'm interested in the holistic health of our entire Southern California area. I can't be everywhere at the same time, but if you think you have trouble or you think you have pest problems, I'd be happy to come and check it out for you because I think it's really great or good. So, anyways, so botanicals. What are botanicals? Botanicals are inputs that are plant matter additives to the brewing process. Most people think of hops. But really before the turn of the millennia, actually, the first millennium, beers weren't all that hoppy, depending on where you made them, and they ended up being very sweet because of this. There was a mixture of spices and other botanical inputs that people would put in there that would make them kind of sweet, and they weren't actually very bitter at all. So when you talk about traditional beer, it was on a time scale. How traditional do you want to be? Do you want to be traditional from like the 1600s, or do you want to be traditional from the 600s? So like hops, barley, wheat, but you've also got coriander, grapefruit, anise, all kinds of things. So if you ever want to homebrew, don't let anyone tell you that you can't put this in there. Because you can, and you should always try it, because I'm a scientist and I like to experiment anyway. Although I have heard that watermelon's not a good additive. But maybe you'll prove me wrong. So botanicals impart phytochemicals during fermentation, and I know that I'm not supposed to read off the slides. I know you taught that in 10th grade, but I'm giving the presentation now. Not you, Mrs. Robinson. So phytochemicals are chemicals made by plants. That's what phyto means. And anyone who's smoked the wacky tobacco or does anything like that has probably heard of what terpenes are. Terpenes are not just in cannabis, however, they're in all kinds of plants. You've also got phenols. You've also got humulones and lupulones, which are found in hops cones particularly. But all kinds of chemicals that are made by plants are, we're sensitive to them. They give different tastes, and that's just the first part of flavor. There's taste and there's aroma, which obviously has to do with your nose. And you put those together, and you get a complex thing called flavor. And depending on your physiology, it might be different from another person. You might have something different from you and me and some other person. But generally speaking, phytochemistry is what makes beer and wine and all other kinds of alcohol what it is. Right, so IPM specialist. So I work a lot with plants and trying to make sure that good bugs kill bad bugs, and you have your biologicals that affect the detrimental organisms. But the plant can do this too by its own accord. It's got a defense system and an immune system and all this sort of thing. You've got these things called volatile organic compounds, and those are things that are released when pests and pathogens try to move into the plant and try to infect it or eat it. And a lot of those compounds are what we are getting in our alcohol. They are the kinds of things that are in our fruits and our other additives that we put into the alcohol. The alcohol extracts it out because of chemistry and how it works. So a lot of the things that you might like that smell pleasantly or smell accurately or taste really good are actually things that are probably meant to make you not want to eat it. But just like alcohol, we've kind of told Mother Nature to take a hike and like it. So as you drink your literal poison, you also drink all the compounds that are in fruits and vegetables and leaves and things like that are meant to abate you and other sorts of things from eating the plant. Right, so human phenotypes vary in sensitivity. For example, myself, how many people here like cilantro? How many people here? Wow, okay. Does anyone not like it? Okay, cool. So there's a genetic component to that. There could be a social component to that as well, but there's a genetic component to that too. I lack the sensitization gene to the compound in cilantro and also coriander that makes me not like it. And some people have this gene and some people don't. And we've been able to find with genetic sequencing that some people from Middle Eastern descent have this. And that's just how it is. And the evolutionary reason for this is kind of lost to history, at least at this point. But you should know that a lot of things that you find negative or positive with regards to aroma and taste has an evolutionary background, has to do with your genes. And then you've also got compound. So aroma and taste. So you've got you've got sweet, sour, bitter, savory. You've also got salty, but typically that's not in beer and wine and things like that. So I omitted it in this slide. But you got different compounds that account for those things, and depending on your ratios of those compounds and chemicals, you get certain tastes. I mean, it's not a very complex topic. I mean, it's not very complex at the surface level, but it gets really complex as you go into it. And that's why I'm not a chemist. So yeah, so just to go over that a little bit more, you've got your different pathogens here that might. So they try to go into the plant. The plant detects this with its immune system, just like things in your immune system detect pathogens, and there's this physiological process of upregulating and downregulating genes that produce terpenes and salicylic acid, which is what this assay is supposed to be, and jasmonic acid and ethylene and things like this. And those pathways basically they stymie the ingress of pathogens and pests. Some pests, however, have grown to be okay with this, and they just sequester it into their body, and they even can use it to poison other things and eat them. How many people here know what a monarch butterfly is? Right, all of you should. Save the butterflies, right? But if a bird were to go and pick off a monarch butterfly and try to eat it, the alkaloids that is eaten as a caterpillar may dissuade him, and oftentimes does, and makes it spit him out. And then it recognizes that color pattern and goes, I don't want to eat that. And then when another organism that comes in that has a similar mimicry about it, the birds will not touch it as well. And that's another aspect of evolution. Right, so I've already kind of touched on this, but aroma and taste. So aroma is chemical driven and taste is chemical driven. But like when you bite into like a tomato or an apple or a pineapple or something, you are inundated with tons of different chemicals. And it's not just each chemical in isolation, it's all of the chemicals together. And if you like go to like take a big old bite of some fruit or something, you might also get a whiff of it too. And so that there's a very complex arrangement of like maybe 100 different chemicals for the taste and maybe 100 different chemicals for the aroma, and they're all interacting the same way. And then you have them all, both of those groups interacting at the same time. And that makes for a very unique experience. So I work with biocontrol agents, but I also work with pesticides sometimes, and it's kind of the same way there. You might have a biocontrol agent that you might buy, and it has an active ingredient and it has some organism, but you might have 5 different companies that make 5 different products. But it's not just the product. You might go, oh, well, they're all the same, right? And I used to think that way too, but it's not the case. The formulation of that pesticide or that organism or that isolate, maybe they engineered it a different way, or maybe they found it in a different place on the earth, and maybe it has different attributes, just like each one of you have different attributes, makes it more or less adapted to certain circumstances. So really, you can't just presume. That's really where it comes down to. Okay, so the source. So all botanicals kind of, when it comes to making and brewing alcohol at a facility like this, you have to source your product. And some places might be a better source than others, and some places might make relationships with certain places because they really like the hops, or they really like the fruit, or the whatever you're putting into your alcohol that you want to put in. And how many people here garden? Okay. Some people try. It is San Diego. But anyone here drink wine? Okay. A lot of people here. I'm not surprised. So one interesting thing about wine and being a vinter is that you might think that babying your plants and making your plants really, really satisfied and watering them appropriately and making sure they grow great and verdantly and large or whatever is exactly what you're supposed to do. Happy plant equals happy fruit. But that's actually not always what you want. And what I mean by that is, before, I mentioned that different compounds are produced by plants for different stressors. There's biotic stressors, your pests and your pathogens, but you've also got abiotic stressors. desiccation in soil, is it really hot, is it really dry in the atmosphere, things like this. And that can cause the plant to wilt, it can cause the plant to go into a sort of panic mode and produce these compounds that we want. So it kind of sounds really, it's kind of mean, but like if you stress out a wine plant, Vitis vinifera, you can increase the malic acid production, and that's what this graph is supposed to be articulating to you. I'll read it to you here. It says, Figure 6, relationships between must, which is all the grape rinds and things like that in the wine brewing process. Must malic acid concentration in vine leaf area. So you've got vine leaf area here at the bottom, and you've got must malic acid concentration, and you'll notice that it does indeed increase. It increases in regards to desiccation in the soil. So if they let the plant dry out quite a bit before fruit sets, they can make the plant go, oh man, I really need to put more malic acid into this fruit. And that causes the fruit that results from that to be quite a bit more sour and also have other compounds in it, so that when they put it in the brewing process for making wine, it is noticeably and demonstrably different from a chemical standpoint and also from a taste standpoint. So if you want to keep that quality, you want to keep that sort of technique, but you wouldn't necessarily think that by making your plant stress that that's what you should do. How many people here have grown peppers? Okay, a lot of people. Do you guys like your peppers hot, or do you like them mild? Hot, okay. So it's the same kind of thing with peppers, actually. You dry them out, and some people, like you see, are nodding their heads. Yes, if you desiccate your plant, you let the plant dry out, the plant will respond by making the capsaicin, and that's a defense mechanism, making sure that the fruit is less likely to be eaten. I guess it's not really the same as dealing with the desiccation, not that it could do very much without that, but the capsaicin will ensure somewhat that certain pests at least will not be able to eat the fruit, and that the seeds will be able to fall and be eaten by birds, which actually don't have receptors for capsaicin. And that's actually it, which is a little bit shorter than I expected. Sorry about that. I felt like I had more to say than that. But I will say this. Do you have any questions? Okay.
You said you were focused on good bacteria beating bad bacteria. How do you feel like that relates to the microbiome, or have you explored that aspect?
Absolutely. The question was, good bacteria, bad bacteria, how does that affect the microbiome? Well, there's this concept that's kind of coming into fruition nowadays called the holobiont. The holobiont is all the genomes in an environment put together. So when you consider your body, you're a composite organism. There are microbes in your stomach, in your intestines, in your gut. Your cells are obviously, in a way, microbes, and your white blood cells even could be considered microbes under certain kinds of classification. So the answer is yeah, it is something that I deal with, and it's also true with plants. You've got things called endophytes. They'll go into the plant and they'll colonize the plant asymptomatically, so they don't cause physiological harm, which is the definition of disease. And sometimes they're mutualistic, like ectomycorrhizal fungi, and sometimes they are really helpful because if a plant goes in, it'll get into the tissues, and a bug comes in and eats the tissues, but the fungal tissue is also there, and it will infect the bug and it will go away and it will die. And that's really great for the plant. So that's a really great relationship to make. And that's something on the forefront of microbiology. But even for human health, ostensibly, if that can happen with a pest, that can happen with a person too. And so that's an aspect of research that is kind of in its infantile stages. Any other questions? Yes?
What beer do you recommend here tonight?
What beer do I recommend here tonight? Like based on So originally I wanted to make this presentation so that people could have good recommendations regarding the compounds that would be in them. But the list that I got did not match the list that is up here today. So, unfortunately, I won't be able to do that. But I really liked the landfall, to be honest. Yeah, a lot of people see. How many people have had that before? Oh, really? Okay, I highly recommend that. I really like sour beers, and I liked it with the raspberry additive. But even if you take no additives, it's still pretty good. Any other questions? Yes.
How do you feel about kombucha?
I like kombucha. You mean like regarding like the microbiome?
Yes.
I think that there are some health claims that are exaggerated. But I also think that, just like the example I gave you before, there is something to it. Not everything survives the stomach. There are actually cases where microbes that live in your mouth, and like, not to gross you out, I'm sure you guys are all aware, there's tons of them, and sometimes they're always constantly growing, they're always constantly evolving in your mouth, and you kiss somebody, you get some different microbes. But sometimes a mutation happens that allows the microbe to travel down your esophagus and actually survive your stomach acid. And maybe sometimes that's a bad thing, because once it gets into your intestines, that's a totally different environment. And what colonizes your microbiome can possibly affect things like irritable bowel syndrome, which is a really mysterious disease. It seems like there's a bunch of different kinds of things that cause it. And part of that is your microbiome and what colonizes it. So the long and the short of it is that I really think there's a lot to it, but we just don't have a lot of the information and data sets. But hopefully in a few decades we'll have that. I don't think it's a bad thing. I mean, like, what is bad and good? Not to get philosophical, I think that's more your thing. But not to get too philosophical, but like, we're all here coming to a brewery to drink literal poison. Not to make anyone feel bad, but I do it too. And we have a finite life, and if it makes you feel good, that's all there is to it, right? Like, come on. Yes. Not a pest, not if I'm not doing corporate espionage. But typically when it comes to like pest control and things like that, there is a jack of all trades I like to use, which is a fungus. It's an entomopathogenic fungus, which is a fancy word for saying it eats bugs, and it's called Beverages bassiana. And what I like about it is because it kills about more or less 700 different species of pest organisms, which makes it really great, in my opinion. You can root drench it, you can foliar spray it, it's not toxic to people, unless you're really immunocompromised, then there are a few cases where people have been infected with it, but if you're immunocompromised, a lot of things can infect you that normally cannot. And you can buy it without a operator identification number. So even somebody who's not a agricultural commercial thing can go out and buy it and spray it on their plants, not their pants. Anything else? Yes. What's the name of what? Beverages bassiana. Oh, you mean well, that's the name of the organism, but a product that you could buy that I like, not to endorse anything, but Botanicals or Mycotrol is a product, are two different products by I think two different companies. That way it doesn't seem like I'm playing favorites. But Beverages bassiana is the active ingredient in both of those products, and if you have like scale insects or aphids or things like that, you could spray it. And the best part about it is that's not a chemical, so you can't like risk like a phytotoxic effect. At least if you get the wettable powder.
Is it called microtroll?
One of them's called mycotrol, like myco, like mycology, and troll, T-R-O-L, not L-L. And the other one's called Botanigard, and it's not Botanigard like on guard. It's Botana and then Guard, G-A-R-D, which I thought was kind of funky, but yes. Oh, I'm glad you've given me a chance to plug myself. Thanks so much. I'll give you your $10 after the meeting. No, I'm just kidding. But yeah, so I wasn't sure how much credibility this would give me, but I'm on Instagram. Yeah, I'm on Instagram as SyncAngel, SYNCHANGEL, and I have a little bit of a following there. I also head up a YouTube channel called Zenthanol, which is what this refers to. I like to talk about pests and pathogens and plant physiology and all kinds of stuff I have videos on, because it's really important to me that people don't need me. I know that sounds like a bad business move, but I really do think it's important that people are able to take care of their own plants, and that my knowledge, like I'm not a knowledge silo kind of person. They're very much an open. People should have access to this information. It shouldn't be esoterica, and as we grow to know more information, people should be able to learn it and know it and use it. So, hope that answers your question.
We're looking at
SYNCH, like synchronize.
Oh.
ANGEL, like angel. Yeah, no problem. Anything else? I think that's it.